All right, so let's just try the same process now. Instead of sandwiches, let's try with chemical reaction. So what we have here is this iron 3 oxide combined with solid carbon to form pure iron and form carbon monoxide. This is oftentimes how they extract metal from the earth, right? You dig up a bunch of metals from the earth, but they're not just by themselves. They're usually as their oxides. And so this is called reduction. You need to reduce it back down to its elemental form, where you can then make it into a steel bar and all kinds of useful things. Anyways, whenever we're doing any sort of these problems, the first thing we should always check is that our equation is balanced. And we can see from the start, we have 2 irons on the left, and only 1 on the right. So this equation is not balanced. So of course, the first thing we have to do is balance it. So let's see, we have 2 irons on the left, 1 on the right, 3 oxygens on the left, 1 on the right, 1 carbon on the left, 1 carbon on the right. I'll go ahead and balance out the irons out first, since that's what comes first. So I'll put a 2 right there. Boom, that was pretty easy. Put a 2 right there. Next up is the oxygens. We need 3 oxygens on the left side, so I'll change that to a 3, but then that'll change the carbons to a 3 as well. And then on the left side, I can simply change this to a 3. And so now our equation should be balanced. Of course, you want to double check. 2 irons on the left side, 2 irons on the right, 3 oxygens on the left, 3 on the right, 3 carbons on the left, 3 carbons on the right. So we're balanced. I'm just going to rewrite this equation. All right, so let's take a look at our question here. So we're going to say that we combine 25 grams of this iron oxide with 6.0 grams of carbon and get 15 grams of iron. What is the percent yield? And so we're going to follow our steps, right? So the first step is to figure out which one is our limiting reagent / the theoretical yield. And so what we can see is that we have 2 different components. So we're going to have to find the theoretical yield for each component. Let's go ahead and start off with our 25 grams of our iron oxide. So we have 25 grams of Fe2O3. Anytime we have grams, we almost always want to change it to moles. So to do that, we need to find our molar mass of our iron oxide. So let's see, iron is 55.845. So 2 times 55.845 plus 3 times oxygen, which is 15.999. We get 159.687 grams per mole. So that'll allow us to go from grams to moles. 0.687 grams, 1 mole up top, grams and grams cancel out. Now we're at moles of iron. Next up, what we need to do is change our moles of iron to moles of or iron oxide to moles of just iron. We're going to use our stoichiometric coefficients. So we can see there's a 1 in front of the iron oxide. So just 1 Fe2O3, and then that'll cancel out with that. And on the right side, we see we get 2 irons out of that, 2 Fe. Now, if you think about what units we're at moles of iron, but we don't want to be at moles of iron. We want to be at grams of iron. So whenever we go from grams to moles or moles to grams, we have to use our molar mass. In this case, it's just iron. So the mass of iron is 55.845. Note that moles is up top here. So moles has to go down here. So this 55.845 grams goes up here. Moles and moles cancel out, and we get about 17.49 grams of iron. Note that in this case, we have only 2 sig figs right here. So in our answer, we should only have 2 sig figs. However, we don't want to do any rounding until the end. So what we're going to do is just underline our uncertain digit, the 7, and then we're going to keep the 2 numbers after it just for some bookkeeping. Later on, we'll round it, but we don't want to round at any intermediate step because each time you round, you add error, right? If I were to round this 17, essentially 0.49 down to 17, I've inserted error there. So I don't want to do that until the very end. So there's my theoretical yield for the iron. Now I have to do the same thing with the carbon. So I have 6.0 grams of carbon. We have to change from grams to moles. The molar mass of carbon is 12.011 grams per mole. And the grams goes down on the bottom because it's up top there. Now I'm at moles of carbon. I want to go to my moles of product. So I can see I need 3 carbons. And then carbon and carbon cancels out. And that'll only get me 2 irons. And now I'm moles of iron. I want to be at grams of iron. So moles down here. So it cancels out with this moles. And then 55.845 grams right there. Now I'm at grams of iron. So I go ahead and do the math and I get 18.60 grams of iron. Again, I'll underline my 8 because that's my uncertain digit. And then I'll take a look at my 2 yields, right? So one of them is lower than the other, and whichever one's the lowest is then your theoretical yield. Which then tells us that the iron oxide was our limiting reagent. Right? It's the thing that's going to produce the least amount of product. It's going to limit how much product we can get. We can only get about 17.49 grams. We can't get 18. No matter what you do, you're not going to get 18 because you don't have enough iron oxide. Cool. So after this, we want to calculate our percent yield. And remember that our percent yield is our actual yield over our theoretical yield times 100%. So our actual yield was given to us in the question, right? It says, and we get 15 grams of iron, right? So that's how much we actually got. So 15 grams up on the top over the theoretical yield. Theoretically, we could have gotten 17.49. With the uncertain digit right here. Again, we don't want to do any rounding until the end. And now we can plug it into our calculator and then round that value, right? Don't do any rounding until the end. And so 2 sig figs, this would go to 86%. So we only got 86% of the product that we were supposed to. That's actually a pretty good yield. The yields that you can expect are really dependent on the reaction. Some reactions will get very close to 100% yield. Some reactions only get 10, 20% yield. It all depends on the individual reaction. And of course, you guys have seen an example of this now, but that's not going to help you too much. What's really going to help you is some practice. So take a look at that work along or the extra resources or stop by office hours.